Hello everyone, in this video I would like to cover half-angle formula, double-angle formula for sinusoidal functions for competition math. So here we go. We have, first let's just go over the double-angle formula, and I would like to start with sine to x. Well, as you can check that sine to x is just going to be sine x plus x. So according to the rule, well, sine x and cosine x plus cosine x, and we get sine x. Well, we can easily write this as 2 times sine x cosine x. And that is going to be how we solve for sine to x. Sine to x can be written as 2 times sine x and cosine x, and we could have used the same similar strategies for cosine to x. Right, so here we go. We have cosine to x, which will turn into cosine squared, cosine times cosine, cosine squared minus sine squared. And we can also use the circular trigonometric identity to switch sine squared into 1 minus cosine squared. And if I switch sine squared into 1 minus cosine squared, then I can rewrite it as 2 cosine squared. We have 2 cosine squared minus 1. And at the same time, I can also leave sine squared alone, but switch cosine squared into 1 minus sine squared. And if I switch it, well, we get 1 minus 2 sine squared. All right. So that being said, we have, like the formula that, we just deduce all those formula for sine to x and cosine to x. And starting from here, we can talk about half-angle formula. All right, so in order to deduce half-angle formula, we're going to use this equation and bottom equation out here. All right, so let's rearrange all of these expressions. Okay, so here we go. We have 1 plus cosine 2x. Well, if I cut it out, or if I divide it out by 2, we end up getting cosine squared. As you can check from this example out here, the second to last equation, well, if I just simply add it by 1 and somehow use some algebras, well, we can find it out in this following form. Now, instead of calling 2x and x, we can actually use those relationship between 2x and x. I would like to call this as theta and theta over 2. So we have 1 plus cosine theta over 2. Well, I can actually write it as cosine squared theta over 2. So that becomes half-angle formula, right? So use the same strategy for the bottom equation. We get 1 minus 2 sine squared. That's just going to be equal to cosine 2x. Moving it around, we have 1 minus cosine 2x. Well, that divided out by 2, just going to be sine squared. All right, so sine squared x. So using the same approach as we've done for cosines, well, I'm just going to call 2x as theta. All right, so 1 minus cosine theta over 2. Well, that turns out to be cosine squared. Well, wait a second. That's not cosine squared. That becomes sine squared theta over 2. All right, so we have just deduced almost everything. If you just look at the screen right now, we have deduced sine 2x equals 2 sine x and cosine x, and we can also see that cosine 2x equals cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. And also we have deduced that cosine squared theta over 2 will be 1 plus cosine theta over 2. Sine squared just going to be 1 minus cosine theta over 2. And these are the formula that you need to know for sinusoidal functions for half-angle and double-angle formula.